cosine at 0 is 1, so 1 over 1 is 1. A lot of words to say that secant squared of 0 is 1. So it ends up being 12 over 5.
Okay.
Any questions on that?
No?
Yeah. So let's move down, slide down the page to like number 5. All right, so and I think it's important to show this. I don't know that I would believe a student could just mental math this, but maybe they could. This ends up being 0 over 0. At least like to see something in that direction.
Okay.
So the derivative of the top this time, derivative cosine is minus sine, but it's already got a negative, so you get sine x over 2x. Problem here is it's sine of 0 over 2 times 0. It's again 0 over 0, so you got yet another indeterminate form. And so you again need to
Take the derivative.
take a derivative. Derivative of sine is cosine. Derivative of 2x is 2. Now we've got it.
Okay.
Any questions, thoughts on that before we?
No, that all seems pretty easy, makes sense.
So try this one on your own. I'm gonna look for some more difficult ones, and then we'll talk about the other cases of L'Hopital's rule to look at.
I got 2 over 9.
I'm having some technical issues here. Give me just a moment here.
Okay.
Be back with you. Okay, I'm gonna need just a few more minutes. Like I said, I don't understand. This happened the other day. Having some unusual problems here.
Okay, no worries.
Be right back with you, hopefully. Interesting. All right, I am back, and I
Yeah.
do apologize. I think I may have figured out what the issue is. You said you got 2/9 here.
Yeah.
Okay, that sounds right. It is indeterminate form like that.
Yep.
It is that we've got an issue here where the we've got an issue here where it becomes 2x over 3 -3 sine 3x. Does that look right to you? And then you get
Yes.
0/0 again. You are
Yeah.
supposed to write the limit each time.
Okay.
So again, you get 2/9. Stirred sine is cosine. So I don't know if I heard the negative. Did you say negative?
I did not. I didn't put the negative after in front of the cosine the second time. I didn't bring it down.
Okay. So there's like a lot of other types of problems that you'll see. Um, like I guess let me put up one that you might see on a tester because I don't know how difficult to make these, but this one requires you L'Hopital's rule a bunch. Um,
Okay.
does this seem like something well, not a bunch, a couple times. Does this seem like something your instructor might give you?
Yeah, it could be
Okay.
definitely.
So when you put in -1, you end up getting -1 to the sixth minus 1, which is 1 minus 1, which is 0, over -1 to the fourth minus 1, which is
0.
1 minus 1, which is 0. So you get 0/0. So go ahead and proceed. Take your derivative and see what happens. Now, in this case, it's 6x to the fifth over 4x cubed. You are allowed to simplify.
Okay.
It's really a limit as x approaches -1 of 6x squared over 4. And you always go back to just trying the number.
Okay. 6x squared over 4. And then -1. So 6 over 4?
And what does that reduce to?
3 halves?
Yeah, very good. All right. You're going to see the problems involving other functions besides what we've been looking at. So let me have you try this one, please.
Okay. What's e to the 0th power? Or to the power of
It is
0?
it is 1.
Okay. Isn't it just -1?
That's your final answer?
I think so, yeah.
Okay, so 0/0 over 0. So then your derivative is e to the x over cosine x. What is e to the 0?
Wait, wait. I didn't take the derivative. I literally just plugged 0 in.
Don't you get 1 minus 1 on top, though?
Oh, never mind. I did that wrong.
Try that again.
Okay. So in x. Oh, I get 1/1 anyways. Okay. I just got 1. So.
Yeah, sorry, you got it. You got it.
Okay.
Yeah, it's 1/1. Make sure you write that limit. Okay, so there's a bunch of other indeterminate forms that you might see, and this isn't to like scare you or worry you. It's just to like let you know, like we've covered that one, and there's a bunch more.
Yeah.
How many of these did you guys see in class?
All of them. We have them all written down.
Okay, but how many of them did you actually get examples for?
Um, All of them except the infinity minus infinity.
Okay. I mean, other than just giving you some problems, like we'll just throw a more challenging one up in front of you. This is the limit as x goes to infinity. So you kind of got to know like what happens to each of these. You're like, all right, what happens when you get e to infinity? E looks
Okay.
like that. So that goes to infinity.
Okay.
Natural log also goes to infinity. And then 5x also goes to infinity. So
Okay.
this is infinity over infinity. So if I'm grading you on a test or quiz, like I want to see the indeterminate form each time. I want to know which one you think it is. Um, and that's like, to me, that's a big deal. But I don't grade your tests, so you should go off whatever your teacher wants.
Yeah, my teacher wants that too. So.
Okay. The next thing is to be able to take a derivative. So I'll do the hard one. Not really. Um, top one here is chain rule. So give that one a try for us, please.
Um, e to the x over 1 plus e to the x?
Yeah, now this is where you really want to rewrite this by multiplying the top and bottom by 1/5 here. And you can
Okay.
do that. You can simplify as much as you need. Limit as x goes to infinity. E to the x over 5 times 1 plus e to the x.
Yeah.
What happens here? Does this work out or is it another indeterminate form?
It's another indeterminate.
And which one is it?
Infinity over infinity again.
Good. So now you got to take another derivative. That's where it might have been good to write it out. So it's the derivative of the top is e to the x. The bottom's derivative is 5 e to the x. And you can cancel those. When you cancel, what's left over on the top?
1 over 5.
Yeah, that's your answer.
Okay, that makes sense.
Okay. Questions on that?
No.
We're gonna keep going more difficult ones, but why is all right, homework examples. Oh my gosh. All right. Searching for some problems here. A lot of them are like the basic ones we did, so they're not all that useful. And I want to like I gotta be careful not to choose them so difficult that you can't know where to proceed. Okay, here's one for you to try on your own, please.
Um. Okay. I'm so I took the derivative and I got 1 on the bottom, so it's obviously not indeterminate form.
Well, what did you get for indeterminate form to start?
Infinity over infinity.
Okay. All right, good. Yeah, so derivative of the bottom, that one's good. What about derivative of the top?
I did 3 ln x squared
You gotta be really careful here. It's the whole thing squared,
all over x.
and then the x goes down to the bottom. So this is indeterminate form again. Now, if that wasn't clear, like it is 1 over x, but you have like this is now your bottom, that's now your top.
Okay. Okay. Okay, you get 0 because it's a constant over x.
Yeah, you keep getting the same. You get 6 natural log of x over x, and then you get 6 over x.
And that's 0.
That's 0. Yeah.
Right.
Okay, and I'm really bad with notation because I don't need to be, and I'm not graded, but you really have to show all this each time.
Okay.
Let's see what else. Doing really well on those. Okay. Yeah, I mean, there's trying to decide how like much detail I should give you. Does your teacher tend to give obscure questions or standard ones?
Yeah, kind of. It's really iffy.
Yeah, so sometimes you see like it would be like x to the 100 over x to the 101 power plus 2 or something. Um, there's a pattern. Like you'll see like things start to cancel. And we're not going to do this example, but like this is kind of a crazy example. That's what I'm wondering. Does this seem like your instructor style or not? Because
Not like no, it doesn't really.
all right, let's not do that. So then the next type of problems you're going to see here is where you have, and I think we did this with like logarithmic differentiation. We talked about something like this.
Yeah.
So this is and maybe you thought this an example of the class, but this is 0 to 0. That's another one of these lovely indeterminate forms.
And then you turn it
And
into an equation,
what,
right?
say it again.
You turn it into an equation, make it ln, natural log of
Yeah,
x.
like I treat as y as x to the x. You take the natural log of both sides, so it's x natural log of x, like that.
Yeah.
So you're taking the limit here of this thing now where it's x times natural log of x, but this is also kind of a problem. Um, you have to know how to rewrite this, and this could be a little bit awkward. So this is natural log of x over 1 over x.
Yeah.
You've seen that before?
Yeah.
Okay. So if you remember that, and it's from the right, I'm supposed to write that down. The natural log as you go to 0 goes to negative infinity. 1
Mhm.
over x graph looks like that. As you go to 0, it also goes to infinity,
Okay.
positive. So you got indeterminate form again. So you take a derivative of both. So it's 1 over x over minus 1 over x squared. And then what does this reduce to? That's kind of a key thing here.
Mm, I don't know. Um.
This is from your previous courses. You,
Uh.
you multiply top and bottom by the reciprocal of the bottom.
X squared over -1.
Yeah, so what does that simplify to?
Um. Hold on. X squared over x over or -x/1. I think.
Okay. So yeah, that's right. So it's really the limit as x approaches zero, -x/1, which ends up being zero. But
We have the
but
ln.
yeah, so it was really that it's the natural log of y equals zero.
Mm-hmm.
So you have to take the e of both sides, so y equals one. So your limit is actually one. This last step is often forgotten.
Okay.
Does that make sense?
Yeah.
Okay. All right. So let's do another one. Let me see if your book has a better one than this. This one's more complicated. Okay, so let's do I guess they do that. All right, let's do 22
Okay.
from your book. So this is also the same indeterminate form. It's sine of zero is zero.
To
So
power
sine of
zero.
zero is zero. So you get that indeterminate form. So this is your y. And I like to write it off to the side here. So your natural log of y is sine x, natural log of sine x. Okay. And you really want to rewrite it. It's almost always, there's always exceptions, one over the thing that's in front like that.
Okay.
So it's really, now we're trying to find the limit as x goes to zero from the right of natural log sine x over 1 over sine x. So tell me what kind of indeterminate form this is now.
Um. 0/0.
Okay, so
Right.
sine of zero is zero, but what's the natural log of zero?
Um. I don't
So
know.
it goes down,
1?
down forever,
Is
minus
it?
infinity.
Oh. Okay. Hold on. I need to write that down.
And sine of zero is also zero, and 1 over zero ends up being infinity.
Okay.
And this is the start of like calculus to calculus 2, where you really have to actually know all the stuff from your previous courses. A lot of students struggle in calculus 2 because they don't remember what graphs look like. They don't remember their trig.
Yeah.
Understandable, like I get. But and there's more of this kind of like work off to the side that's not really part of your problem. That
Okay.
is also frustrating. So now we're going to take some derivatives. So can you give me the derivative of the top?
Uh, cotangent x or cosine
Uh,
x over sine x.
okay, yeah, that's better. So it's cosine x over sine x. And then bottom is quotient rule or our rule, maybe, followed by chain rule.
Um,
Depends on how you look at it.
hold on. 1 times. The derivative of 1 is just 0, right?
That's right. Yeah.
So cosine x over sine x squared?
Yeah, that's right. Although I think we gotta have a sign, we gotta have a negative somewhere.
Mm, wait, why?
Well, so you're probably doing bottom times derivative of the top minus the top times derivative of the bottom. Derivative of sine is cosine over bottom squared.
Because of the negative.
Uh,
Oh, or the
yeah.
minus. Okay.
Okay.
So
So
negative.
again, probably a good idea here to simplify this.
So multiply
Could
by
you,
the reciprocal?
yeah, could you do that for us, please?
Yeah. Don't they just cancel to 1 over 1?
There's a squared on the bottom
Oh,
here.
never mind. So sine x over 1 and then plug 0 in turns into 1 over 1?
Yeah, it says becomes the limit x approaches zero from the right of sine x. Sine of zero is zero.
Yeah.
Yeah, questions on these?
No.
Okay, so the other way to do these that, like if you're doing these on your own for practice, is you could graph this, which I'll do now, just so you know the answer. Like I know you can't do that on the test or quiz, but
Yeah.
in real life, we're not bound by silly things like you know, not being able to use technology. So let me grab a snip of this. So here's what the graph looks like. This is pi over 2, the red line, sine x to tangent x. So we know the answer is 1. Okay,
Yeah.
so sometimes it's like really good to know the answer. And it's from the left, not that that matters. The problem is from the right, it's the same. Um, this is exactly like the previous problem where you have to take a natural log of both sides. Oh, I'm sorry, one more thing. I always it's that natural log of y equals
Oh,
zero.
yeah.
So it's e to the zero equals one. It's not always e to the zero. Like sometimes it is one or ends up being something else. Um, but could you try getting as far as you can on this one on your own, please?
Yeah.
If you have questions, please ask.
Okay, I got 1.
But is that, you mean when you say one, is it like that's the final answer, or did you get 0 and then e to the 0 is 1?
Well, I got e to the 0 is 1.
Okay,
Whatever I
perfect.
get the other number.
Okay, now really quickly here, tan x, natural log of sine x. How did you change tangent? Did you go 1 over tangent or did you go to cotangent?
I did 1 over tangent.
Okay, which is cotangent, by the way. So like another way to, that's where, having this trig could really help because that's slightly easier derivative. Minus cosecant squared x, 1 over sine x, like that,
Yeah.
cosine x. And then, you can go from there. Like there's a bunch of ways to do it. So sometimes it's nice to know what the actual answer is ahead of time.
Yeah.
All right. Moving along. Okay. Here is a problem that we've already done, but kind of that we've already done, but we'll talk about it. So another technique that I think they tend to emphasize here is that, and this is one of those again and again, another one of those indeterminate forms, um, kind of. Um, like this is 1 over 0 minus 1 over 0, which is an
Okay.
indeterminate form, but it's if you make a common denominator, that's the type of problem here it is.
Uh-huh.
You can then apply L'Hopital's rule. What would that common denominator be?
Um, it could be sine of 3x, right?
That's part of it. Yep.
Uh, I actually don't know how I'd find the common denominator of that, I'm not gonna lie.
So it's the product of these.
Oh, okay.
And that also helps you just end up multiplying the top and the bottom by the missing piece, 3x times 3x, and then sine 3x times sine 3x.
So it'd be 3x minus sine 3x on the top?
Yes. And it's now it is for sure in this indeterminate form.
Okay.
So could you proceed from here? The bottom one is product rule, unfortunately.
Okay.
Give that a try, please.
Mm, okay, I got to the point where I got a 3 minus cosine 3. Yeah, I got to that.
Okay. So when you put zero in the top, you get zero, which isn't a bad thing. Like zero on the top's okay.
Yeah.
It's on the bottom. Now on the bottom, you unfortunately like this is zero because that's zero and that is zero. So you get another indeterminate form, which
Uh,
it's a little deflating, but that's the nature of these things. So the root of the top is 3 sine x. The bottom is unfortunately another product rule. You might rewrite it a little bit 9x cosine 3x. Um, I know this is a pain. This is a test question potentially.
yeah.
Uh, so let's see another product rule here.
Okay, so 3 sine. Oh, yeah. -9. Okay, yeah, that's what I got.
Right, so 3 sine 0 on the top is 0, which is not great. It's 0 on top is okay. It's not the worst in the world. It's 0 on the bottom. This is 0 because the 0 for x, but cosine of 0 is 1, so that's 9. We're in better shape. Cosine of 0, so this is 0 over 18, which
0.
is 0. Now, if you want to know, like, if you're really stuck on a test or quiz, I mean, a lot of the answers like 0 or 1, you know, that's
Yeah.
that's the possibility. Okay, let's try a slightly better one. Same flavor, different flavor, same type here. Okay, this is another common denominator problem. And if you
Okay.
don't know any better, you just make the common denominator the product of them
Okay.
without getting into like special cases. Okay. Now on the bottom, you do want to expand so that when you take your derivative, I mean, well, it's up to you. You can actually take your derivative either way on that, but you're going to have a product rule again. That's not uncommon. So give that
Okay.
a try, please.
On the top, why do you have. Oh, wait, never mind.
It does go to infinity over infinity. I'm also kind of
Okay.
glossing over that, but
Um, okay, so then for the derivative, I got e to the x minus 1 over e to the x minus 1 plus x times e to the x. And then
yeah,
I
you
need to plug
e to
infinity
the
in.
x plus x e to the x minus 1.
And I'm pretty sure it's still infinity over infinity because e to the power of infinity is infinity.
It is, but it'll get better here the next, well, it does get better. You gotta get rid of the constants basically.
Um,
So you get e to the x over e to the x plus e to the x plus x e to the x. And this time you want to cancel out those e to the x's if you can.
okay.
So you can actually factor them out of the bottom, and it's 1 plus 1 plus x.
Um, okay. So e to the x. 1
Cancel.
plus x. So 1 over 1 plus 1 plus x. So it's 1 over infinity?
Yep, which tends to 0.
That's my answer 0. Okay.
All right, so let's just look at a couple more here. Um, the hardest thing I think is to know how to rewrite something.
Mm-hmm.
This one requires a rewrite that I don't know if it's obvious or not because you're the student that hasn't seen this before. So I would call it non-obvious, but um,
Yeah.
your goal should generally be to get it as something over something.
Yeah. So I have to bring 1 over e to the negative x, right? To the
Except when
denominator.
you except when you bring it down to the bottom, it becomes so just really limit.
Mm. Okay.
So see if you can proceed from here with what to do.
So then I get 1 over x over e to the x. And then that comes back out to infinity over infinity.
Wait, you said 1 over x over e to the x, right?
Yeah.
Okay, so you do want to simplify here. So it ends up being 1 over x e to the x.
Okay. 1 over x e to the x. And then that's still. Oh, wait, that's 1 over infinity,
There you go.
which is 0.
All right, so one last problem here. How would you rewrite?
Okay. Um. Okay. So it's x to the power of 1/2,
Okay,
which
that's
means
true.
I can bring it down, right? And x. Wait.
That's true, but that it's preferred if you rewrite that one.
Oh. 1 over cosine?
Yes.
Okay.
All right, so see if you can do it is 0 over 0 because cosine, I'm sorry. It's not even that anymore because cosine of 0 is 1. So you actually don't even need to do anything.
Oh, perfect.
There are occasionally problems where you don't have to do anything. And that it's the most common one is where you get 0 over a number. So just be on the lookout for that.
Okay.
All right, we're going to stop there for today. Good job.